Hi everyone, it's Linnea Tucker. For those of you that are struggling with simplifying radicals and radical expressions, I'm going to teach a different approach, okay? Different than what I normally teach, because I've seen this approach work for several students, and if you're part of that group that just is not getting this, this might be helpful, okay? This approach is going to be based on prime factorization and expanded form. Okay, let's start really simple. Everybody knows that the square root of 4 is 2. Okay, so prime factorization, what I want you to do is, let me get rid of this. I want you to take what's under the radical sign and change it into its prime factors. So we know that 4 is 2 times 2. Now, with a square root, you know your index is 2. So what that's telling you is to get anything out from underneath the radical sign, you've got to pair them up. If you pair them up, they come out from under the radical sign. A pairing of 2 comes out as 1. Okay? So if you can pair up 2, it comes out from underneath the radical sign. So let's try that again. Everybody knows that the square root of 9 is 3. What I want you to do is take 9 down to its prime factors, which is 3 times 3. And on a square root, you know your index is 2, so that says we're looking to group in pairs of 2. And if you can group in pairs of 2, they come out from under the radical sign. Okay? Let's try a little harder problem, a little more difficult. Let's try 20. If you don't know what the prime factorization of 20 is, you can always use a factor tree. I know 20 is 2 times 10. 2 is prime. I'm going to circle all my prime numbers. 10 is not. 10 is even. It's divisible by 2. 2 is prime. 2 times 5 makes 10, and 5 is prime. There's your prime factors. So I'm going to rewrite this as 2 times 2 times 5. We know our index on a square root is 2. That means in order for any numbers to come out from underneath the radical sign, you've got to pair them up in 2's. So here's a pair. They come out from underneath the radical sign. That brings those out. What's left? A 5. So simplified form of the square root of 20 is 2 the square root of 5. Okay, you see what I'm doing here? Let's try a little more difficult problem. The square root of 72. All right, I got to find my pairs. But first I've got to go find the prime factors. So I don't know what the prime factors are. Here's what you do. I know 72 is even, so it's divisible by 2. 2 goes into 7 3 times. That is 6 with 1 12. 2 goes into 12 6 times. Okay. And if you please use your calculator on this. If you can't do this in your head, and I usually can't, use your calculator. All right, I know 36 is 6 times 6. Oh, 2 is prime. 6 and 6 are not. 6 is 2 times 3. Those are prime. And this 6 is 2 times 3. So there's your prime factorization. So here I've got 2, 2, and 2. 2 times 2 times 2, and a pair of 3's. Times 3 times 3. All right, the index of 2 says in order for it to come out of the radical sign, you've got to pair them up. So here's a pair of 2's. Those pairs of 2 come out as 1, 2. Okay? Here's a pair of 3's. Pair those up, and it comes out as 1, 3. And what you're left with under the radical sign is a 2. So now on the outside, you've got to take 2 times 3, and you get 6, the square root of 2. There's simplified form for the square root of 72. All right, let's try one just a tad more difficult. The square root of 216. Okay, well, I don't know what that is. Let's go to our factor tree. Let's see. It's an even number, so I know it's divisible by 2. Okay? So you're going to take 216 and divide by 2, and you get 108. And 2 is prime. But 108 is not. It's even. It's divisible by 2. 108 divided by 2 is what? 54. 54 is not prime. It is even, so it's divisible by 2. So take 54 and divide by 2, and you get 27. Let's see, 27, if you add those two digits, 2 plus 7 is 9, and 9 is divisible by 3. That makes 27 divisible by 3. 27 divided by 3 is 9, and 3 is prime, and 9 is 3 times 3. There are all of our prime factors. So I've got 2 times 2 times 2 times 3 times 3 times 3. And write it out that way. We're going to expanded form. Bare bones, let's bust it down into its simplest form. Okay, now we're taking the square root. That means the index is 2. So in order for a number to come out from underneath the radical sign, you've got to pair them up. Right there, if I pair that up, 2 times 2 is 4, and you know the square root of 4 is 2. Do you see what we're doing here? So in order to eliminate this under the radical sign, it comes out as a pair of 2's. Because we're doing the square root, comes out as 2. Okay? There's another pair right here. That pair of 3's comes out as 1, 3. And what are we left with under the radical sign? Yeah, we've got 2 times 3. 2 times 3 is 6. Multiply on the outside, you've got 6, the square root of 6. Okay? All right. What if we're doing cube roots? Cube roots work the same way. Okay, 8 is 2 times 4, and 4 is 2 times 2. There's your prime factors of 8. All right? So let's write that. I've got 2 times 2 times 2. But our index here is 3, which means in order for you to cancel things out and bring them out from underneath the radical sign, you've got to have groups of 3. So here I do have a group of 3. It comes out from underneath the radical sign as just 1, 2, and actually there's nothing left under the radical sign. That goes away. Okay, so the cube root of 8 is 2, and we knew that because 2 times 2 times 2 gives you 8. The cube root of 8 is 2. All right, 27. 27 is 3 times 9, and 9 is 3 times 3. So let's use this approach. We're doing the cube root of 3 times 3 times 3. If you can group them in groups of 3, they come out from underneath the radical sign. These cancel each other out, and it comes out as a 3. There's nothing left under the radical sign. All right, let's try a more difficult problem. The cube root of 40. All right, well, let's take 40 down to its prime factorization. I know that's 4 times 10. 4 is 2 times 2, and 10 is 2 times 5. There's your prime factors. So we can say this is the cube root of 2 times 2 times 2 times 5. In order for it to come out from underneath the radical sign, you've got to have groups of 2. All right? I'm sorry, groups of 3. This group of 3 comes out as a single 2. And what's left underneath the radical sign? Yeah, just a 5. So that's your final answer. 2 times the cube root of 5. All right? One more. And then we'll throw in some variables. And don't freak out, it's going to be okay. 432. Let's take that down to its prime factorization. I know that 432 is even, so it's divisible by 2. So if you take 432 and divide by 2, you get 216. 216 is even, so divide that by 2, and you get 108. 216 divided by 2 is 108. 108 is even, divide that by 2, and you get 54. 2 times 54. 54 is even, so divide that by 2. And you get 27. Okay, it's not even. I always like to check that divisibility rule that says if you add the digits and the sum is divisible by 9, then the number's divisible by 3. Let me say that again. If you add the digits, I said that totally wrong. I haven't had enough coffee this morning. If you add the 2 digits in the number and the sum is divisible by 3, then the number's divisible by 3. Okay, got it right that time. So 2 plus 7 is 9, and 9 is divisible by 3. So 27 is divisible by 3. That gives you 9. I feel like I'm running out of space here. 9 is 3 times 3. Woo! All right. So here comes our prime factorization. 1, 2, 3, 4. There's four 2's being multiplied together. 1, 2, 3, 4. And how many 3's? 1, 2, 3. Times 3, times 3, times 3. Come on, pen. All right. Our index of 3 is telling us that the only way a number is going to come out from underneath the radical sign is if you can group them in 3's. So let's see here. There's a group of 3. So that comes out as a single 2. And here's a group of 3. And that comes out as a single 3. What's left under the radical sign is 2. So your final answer here, 2 times 3 is 6. So it's 6, the cube root of 2. All right, how do you like that approach? Yeah, I think this might work for some people. This really gets down to the root of what's happening here. Bare bones. All right, so let's take a look at simplifying some of these expressions that have a variable in them. Okay, let's try these two. I've thrown in some variables. Prime factorization of 24. Well, 24 is divisible by 2. That's 12. 12 is divisible by 2. Even numbers are all divisible by 2. That's 6. 6 is divisible by 2, and you get 3. Okay, so writing this out in expanded form, under the radical sign, we have 2 times 2 times 2 times 3 times x times x. What's your index on a square root? That's 2. So that's telling you that you have to have group up identical things under the radical sign in pairs in order for it to come out as a single. Okay? So we have a pair of 2's here. So those will come out as a single 2. And we have a pair of x's. That pair of x's comes out as a single x. And what's left underneath the radical sign? Yeah, that's a 6. And, you know, if there's no index here, we assume it's a square root. So to look professional, like we know what we're doing, we'll just call that the square root of 6. Okay? And that's done. We simplified that radical. All right, well, let's do the same thing with the next one. Let me switch colors. All right, we have, I'll get that all ready. 32, let's find its prime factors. It is even, so 32 divided by 2 is 16. 16 is divisible by 2 because it's even. 16 divided by 2 is 8. 8's divisible by 2. You get 4, and 4 is divisible by 2. There's your prime factors. So we have 2 times 2 times 2 times 2 times 2. 5 times, and then we have x to the 5th, so it's times x times x times x times x times x. 5 x's all being multiplied in a row. Okay, on a square root, our index is 2. So in order for any number or variable to come out of the radical sign, we've got to have pairs of 2. There's a group of 2 that comes out as a single 2. There's a group of 2 that comes out as a single 2. Here's a pair of x's. They come out as a single x. Here's a pair of x's, and they come out as a single x. So those are gone, and those are gone. What is left under your radical sign? 2 times x. Okay, so now we're going to multiply this together, and we get our final answer here. 2 times 2 is 4, and x times x is x squared, the square root of 2x. That's your final answer in simplified form. And I really think the more you do this, then you're going to start to see the shortcut. All right? But this definitely will get you through any test. Yeah, if you're struggling with all of this, this will work. All right, let's see if I've got another one set up. Yes, I do. Let's take a look at this one. This is a square root, so let's go find all the prime factors. This is going to be a really long one when we put it in expanded form. Okay, 72 is divisible by 2. 2 goes into 7 3 times. That's 6 with 1 left over. 2 goes into 12 6 times. Okay, that's prime. 36 divided by 2 is 18. 18 times 2 is 36. 18 is divisible by 2. We get 9. 9 is divisible by 3. Okay, that's 8. Let's see, 8 times 9 is 72. All right, so we've got 2 times 2 times 2 times 3 times 3 times. This x to the third is x times x, come on pen, times x. And then we've got y to the fifth times y times y times y times y times y. We're taking the square root. Our index is 2. So we've got to find groups of 2 in order for that single number to come out. Here's a group of 2. That comes out as a single 2. Here's a group of 2. That 3 times 3 comes out as a single 3. Here's a group of a pair of x's. That pair of x's comes out as a single x. Here's a pair of y's. They come out as a single y. Here's our final pair. Another pair of y's comes out as a single y. And under the radical sign, we're left with what? 2 times x times y. 2xy. Let's simplify our front end. Out here, 2 times 3 is 6 times x times y. Y times y is y squared. The square root of 2xy. Okay? You want to do one of those with a cube root? Yeah, let's try one, and then we'll try a couple other things like rationalizing the denominator and adding and subtracting a few radicals, and we'll call it good. All right? Okay, I'm going to use the same problem, but instead of doing a square root, I'm going to do a cube root. With a cube root, you're looking for pairs of 3. You got to pair up 3's in order for that number to come out. So, here is a group of 3. You group them together, it comes out as a single 2. You can't do that here, but we do have a group of 3 here. That will come out as a single x. And we have a group of 3 right here, and that comes out as a single y. So that cancels those out. Those are gone, and these are gone. So under my cube root sign, and you've got to put that index, you have to put in that index of 3. I've got 3 times 3, which is 9, and y times y, which is y squared. And we are done. How's this method working for you? Okay, let me find a couple extra problems, like maybe one where we're rationalizing the denominator and one we're adding and subtracting, and I'll turn you loose to go and simplify radicals. All right, we need to rationalize this denominator. We don't like leaving radicals in the denominator. So in order to rationalize the denominator, I'm going to multiply that fraction by 1. I'm going to multiply the fraction by what? Well, turn my pad around. There we go. 1. It's not slanted. Okay. Yeah, that multiplying by 1 makes the fraction, any number times 1 is still that number. 1's not going to get that radical, that square root of 3 out of the denominator. So let's use a different form of 1. How about if we do, you know that 3 divided by 3 is 1. That's still not going to get the radical out of the denominator, but this will. So whatever is in your denominator, whatever the radical is, that's what you're multiplying by. If your radical needs to be simplified first, let's say you had something like this, the square root of 4x. Well, the first thing, and that's in the denominator, the first thing you want to do is take the square root of 4, which is 2, and bring that out. And now you're just dealing with your square root of x. So whatever the radical is, that's your form of 1 that you're using. Okay? And I'll get back to this in a minute, because I think I just started something here. So let's erase that. Let's go back to our original problem here. Okay. Now, when I multiply, I'm just going to work with my denominator. Well, let's go ahead and do this in the numerator. That's 24x to the 5th multiplied by the square root of 3. We'll just park that for the moment. Down in the denominator, I have the square root of 3 multiplied by the square root of 3. The square root of 3 times the square root of 3, using that multiplication property, is the square root of 3 times 3. And you just learned if our index is 2, we're looking for pairs, and that comes out as a 3. And that will happen every time. Just take whatever the radical is in your denominator and multiply by that over itself, that form of 1, and you get rid of the radical. Okay, so now we have to deal with our numerator. Here I'm going to change colors. Let's go back to our prime factorization. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So I've got 2 times 2 times 2 times 3. That's the prime factorization of 24. Then multiplied by that 3 that we just introduced. Let me expand this out a little bit more. I need a little more room here. Okay. And then we've got x to the 5th power. X times x times x times x. Come on. Times x. There we go. Our index here is 2, so we're looking for groups of 2. That comes out as a 2. There's a group of 2. That comes out as a 3. Group of 2, that comes out as an x. That group of 2 comes out as another x. And under the radical sign, we're left with what? 2 times x. So here our final answer, when we simplify what's out front of that radical sign, we have 2 times 3, which is 6, and x times x, which is x squared. Do you see what I see? We're not really done. I hope you see what I see. 3 goes into itself once, and 3 goes into 6 twice. Now down in the denominator, we're only left with a 1. So that totally eliminates our fraction. And our final answer here is 2x squared, the square root of 2x. Okay? Alrighty. Talking about this one here that I started, if you do this kind of thing, let's say we still have the 24, no, let's not even, no, let's go ahead. Let's just, I'm going to totally make up a new number here. Let's just put, I don't know, a 2 right here. No, let's make it something else. Let's make it a 3. Okay. What I did first here, as I said, okay, well, that's the square root of 2 times x. That's how the 2 came out from underneath. That's how we got this. I got to get rid of the radical sign in the denominator. The 2 is fine. Leave it there. I'm going to multiply by the square root of x over the square root of x. So that gives me 3, the square root of x in the numerator. In the denominator, I have 2. When you take the square root of x times the square root of x times x. All right? We're taking a square root of x times x. I'm going to put the answer over here. I've got 3, the square root of x. And that x times x pairs up, and it comes out as a single x, and you have 2x. And 3 is not divisible by 2. You are done. I didn't mean for this video to be so long, but I want to give you one more example before I end. No, 2 more examples. 2 more examples. Okay, let's take 20, the square root of 20x to the 3rd, and subtract x the square root of 80x. All right, prime factorization on the square root of 20. That's 2 times 10, and 10 is 2 times 5. And then we have x times x times x. And let's just keep going with this, and then we'll deal with the second term. It's a square root. I'm looking for pairs of 2. 5x. Okay, now we can subtract. Here we have x. Let's do the prime factorization of 80 over here. I know 80 is 8 times 10. 8 is 2 times 4. There's a prime factor. 4 is 2 times 2. Those are both prime. And 10 is 2 times 5. And those are prime. So I have, let's see, I have 4 2's. 2 times 2 times 2 times 2 times 5 times x. That comes out 2 times, don't forget the x, I'll put the x right here. There's a pair of 2's. And what's left under the radical sign is 5x. Okay, well we know that 2 times 2 is 4. So I'm going to change that real quick. Make that a 4. And now we have like radicals. And you can subtract. You treat this kind of like they are, when you did your variables. If you have variables that are raised to the same power, and if you take the square root of something, you're raising it to the 1/2 power. We do have like terms here. I have 2 of these things here, the x times the square root of 5x. I have 2 of them here, and I'm subtracting 4 of them here. So my final answer is minus 2x, the square root of 5x. Okay? One last problem, and I'll see if I can't speed this up just a little bit. Bam, that ought to speed things up, huh? Yeah, I hope you pause the video and do this one on your own, and then we'll compare answers. All right, let's pull stuff out from underneath the radical sign. On this first term here, I get that, and that, and that, and that. Switching over to y's. One more pair. And under the radical sign, we're left with an xy. And simplifying the front end, 2x to the 1, 2, 3 power y squared, the square root of xy. All right, that's the first one. Then we're adding the second one in green. I have 9 times x squared. Let's see what else gets multiplied out front. Here's a pair. A pair of y's. And one last pair of y's. And under the radical sign, I'm left with x times y. All right. Now, when you take your x squared times another x, we are going to get 9x to the third. Y times y is y squared, the square root of xy. Okay? Plus this term in the front. Now let's deal with subtracting 5xy, the square root of x to the fifth, y to the third, which I had to write up here. So we will be subtracting, let's go ahead and write our 5 times x times y times, let's see what comes out. That comes out as a single x. Here that comes out as another single x. and a y. What's left under the radical sign? xy. Okay. So let's see here. We have 5 times x times x times x. That's 5x to the third. And then y times y is y squared, the square root of x, y. And let me go ahead and bring this on down. 2x to the third, y squared, the square root of x, y. I need to go and see if I've got any like terms. Like terms have variables raised to the same powers. And you know, square root, that is a power. That's the 1/2 power. So I have x to the third, y squared, the square root of y. X to the third, y squared, the square root of xy. X to the third, y squared. These are all like terms. That's a like term, and that's a like term. And those are all identical. So our final answer will have that in it since we're adding and subtracting. X to the third, y squared, the square root of xy. So here we're going to take the 2 plus the 9, which is 11, and then we're going to subtract 5 right there, which gives us 6. And there's your final answer. Yeah, I know. Yeah. Just take it a step at a time and go slowly and work through it, and you'll get it. I really hope this helps. If it helps, leave me a comment in the video, give me a thumbs up, just wanting a little bit of feedback. Thanks, everyone.